So this question gives us U.S. median rents in 2014 dollars, starting in 1960 and ending in 2010. Just a point of clarification here, you may believe that these numbers reflect inflation. They do not. In 1960, the median rent was not this high. It was quite a bit lower. What we're doing is we're considering changes in the cost of living and converting those dollars to 2014 dollars. So what this tells us is rents have been going up dramatically in the 50 years reflected in this table, from 2014 dollars of $568 to 2014 dollars of $928 during the course of those 50 years. So cost of living, cost of rent, cost of housing indeed has gone up quite a bit during that time frame. Now this question says use t equals 0 for 1960. So what we have here is we have 1960, 1970, 1980. So our first point, we have 1960 for the year and 568 for the rent. But t equals 0 is going to correspond to 1960. And the rent is 568. So when I start my table, it's going to look like this. My next point is 1970. Well, if 60 is 0, 1970 would be 10, and that corresponds to 670, etc. So we're going to go ahead and fill out the rest of that chart. Remember, t equals 0 corresponds to 1960. We have years since 1960 and rents in 2014 dollars. So let's go ahead and fill out the rest of those numbers. What do we have next? 2698. So 20 years since 1960 and $698. And then we have 3810. Next up, we have 4828. And finally, we have 2010 50 years, 928. So those are the points that we want. Again, T is years since 1960. Y is rents, or X and Y if you prefer. So those are all of our values. We want to put those into the graphing calculator. So I'm going to pull up the TI calculator. We're going to put the data in first. So stat edit. If you have things in those lists, you're going to go to clear list, stat, clear list L1, clear list L2, but I don't have anything in there. So I'm just going to edit those. So my list 1 is 0, 10, 20, 30, 40, 50. And our Y values from our paper, we had 568, 670, 698, 810, 828, and 928. So those are our numbers that we had from our table. And I'd like to see what the graph of that looks like. So I'm going to turn the stat plot on. Second stat plot, notice it's off currently. Hit enter, I can turn it on. And we have different kinds of plots. A scatter plot is what we typically want to use. That's a good mark, good enough. Blue, sure, why not? Then we're going to go to zoom stat. Zoom stat is number 9. And those are the points that we have. Now you may argue those look like a straight line rather than an exponential function, but the reality is most financial things do not follow linear change over time. So we're going to choose to look at an exponential model this time. So I want to find my regression. Where do I find that? Where is that? What do I look for? Let's see, where is it at? Second calc is the button. I remember. Nope. Stat calc, there we go. So one more time, how do we find the regression? Stat button, arrow it over to calc. I'm looking for a regression. So you'll notice I have a linear regression here, quadratic regression, cubic regression, quartic regression, a different linear regression, a natural log regression, and then an exponential regression. So that's what I want to do. We're going to do an exponential regression on this data. And that's fine. My X list was L1. My Y list was L2. It's not frequency. If I have a frequency diagram, I change that. I can actually store the regression equation. That's a pretty good idea. You don't have to do this. But vars, y vars, function, y1, this will store the regression equation in y1. And then calculate it, and we get it. So I'm going to write this down. Y equals a times b to the x. That's our regression equation. That's our curve of best fit, if you will. So A is 587.84. B is 1.009296. Keep a whole bunch of decimal points there. If you round too early, the error propagates. So Y equals A times B to the X. A is 5.87.84, B is 1.009296. Let's go back and look at our question, if we could. So I have the regression equation. It is what Y, so we'll do it this way first. Y equals A, 587.84 times B, 1.009296 to the X. But what was this? This was really T, and this was really rent. So I'm going to write the equation down one other way, namely rent equals 587.84 times 1.00926 to the T, where T is number of years since 1960. So that's our equation. We've done that. Now, what is the question asking us to do? Predict the mean in 2020. Predict the mean in 2020? Well, what would T be? In 2020, T would be 60. So the rent would simply be 587.84 times 1.00926 to the 60th. Let's make sure I copy that down correctly. I want to go back to the calculator. 009296. Let's fix that. 9296, 9296, 9296. There we go. 587.84 times 1.009296 to the 60th. So let me go ahead and do it this way first. And I'll show you another way in a minute here. 587.84 times 1.009296 to what power? To the 60th power, because 2020 is 60 years after 1960, and we get about 1,024. So we predict that the rent is approximately, or would be, about 1,024. Now there's another way to do this, because you'll remember I actually stored the regression equation in Y1, so that contains all of the decimal points. So I could just ask the computer vars, Y vars, function, what is Y1 evaluated at 60? And I hope it gives me 1,024. And notice, it even gives me correct to sense, 1,024.17. So I did have enough decimal points there. So we were able to predict what the rent would be in 2014 dollars, which was our goal. Now our last question here is to determine in what year would the rent be at least 1,500. So let's talk about that. We have this equation, y equals a times b to the x. Y equals 587.84 times 1.009296 to the x. And I want the rent to be 1,500. So setting up this equation, it would be 1,500 equals 587.84 times, be careful with that, 1.009296 to the t. And I want to solve for t. How many years since 1960 will it take before we get to 1,500? This is multiplication. So to undo multiplication, I have to divide both sides by that multiplier. That multiplier being 587.84. Divide the right by 587.84. Divide the left by 587.84. So on the left, we get 1,500 divided by 587.84, and I get about 2.5517. Again, keep a few decimal places here. 2.5517 equals 1.009296 to the t. So to solve for t, to solve an exponential equation, we're going to apply the natural log to both sides. Natural log to the left, natural log to the right. Natural log 2.5517 equals natural log 1.009296 to the t. Then what happens? The t comes down front, and we have natural log 2.5517 equals t times natural log 1.009296. And we'll divide both sides by natural log 1.009296. Natural log 1.009296. What does t equal? And we might as well go back to the calculator to do that. So on top, parentheses, natural log 2.5517. Divided by, on the bottom, natural log 1.009296. And what do I get? 101. T is about 101. So that makes me think a little bit. Remember, that's years since 1960. So 1960 plus 101 is 2061. Now, in reality, it's not a good idea to take these regression models and extend them that far in the future because things change. It really is best to use numbers between the beginning point and the ending point. Of course, that isn't what always happens. But yes, so we predict, though, based on this model, we predict around 2061, average rent in 2014 dollars. Notice that's very important because inflation will be a whole lot more than that. It'll probably be 10 times that. Average rent in 2014 will be at least around $1,500. In 2014 dollars will be around 1,500. If you want to add an extra year to make sure it's above, since I believe we rounded down, you want to say 2062, I certainly could understand that. But like I said, I don't have a whole lot of confidence in my model when the numbers go out that large. But let's go one more time to our graphing calculator. And I'd like to show you the graph that we have currently. So there's the dots I gave you from the table And there is the regression equation that we stored in Y1. And I want to know, when does that thing equal 1500? So I'll go ahead and I'll put in 1500, but I know I need a much larger window because I think X is 101. So my X max better go beyond 55, maybe to 200. And my Y max has got to go beyond 1500, so maybe 2000 is good. And let's take a look at what we have here. So there is my regression equation in blue. And we're going to get Y equals 1500 showing up here shortly. And I could see where they crisscross. So I solved it algebraically on the paper, but I can actually find the intersection point this way too. So the intersection of these two graphs, first graph, second graph, guess, and I get 101. So indeed, the 101 is correct. 101 years since 1960 gives us 2061 when we would expect the average rent in 2014 dollars. I want to emphasize that point that inflation is constantly reducing the value of your money. Will be around 1500, assuming that model holds, which is not realistic, but interesting.